Okay guys, pre-calc classes, this is the beginning of lesson 2.4. We're going to split this up into two parts today. You can see the three objectives. We're going to take care of synthetic division, we're going to take care of the remainder theorem, and we're going to take care of the factor theorem. Tomorrow we will talk about rational zeros, and then we'll talk about finding the upper and lower bounds for the zeros of the polynomials. So this video shouldn't be very long. Synthetic division. Okay, this is a shortcut method for finding both quotients and remainders for division by x minus k without long division. We did long division last year a little bit. It's not really necessary for you guys to know the synthetic division is good enough. Okay, so what we want to do is we want to divide this big long polynomial by x minus 3 using synthetic division. And when it says write a summary statement in fraction form, basically, guys, what that means is write the answer. Write the resulting polynomial plus the remainder. So here's what we're going to do. Because x minus 3, okay, is what we're dividing by, we are going to put a 3 in the box, what I call the box. Okay, so I know it says x minus 3, but it's x minus k is the factor. So if k is 3, then it's x minus 3. Now if it was x plus 3, we'd be putting a negative 3 in the box. So now what goes outside the box? Well, all the coefficients. Okay, so 2, negative 3, negative 5, and negative 12. You skip a line, then you draw a straight line, and now what you want to do is bring down the 2. And now what you're going to do is you're going to take that 2 that you brought down and you're going to multiply by the 3 in the box. So 2 times 3 is 6. That now goes under the negative 3. Negative 3, and then you add down the columns. So negative 3 plus 6 is 3. Now I take this 3 that I got and I multiply by the 3 in the box and I get 9. Negative 5 plus 9 is 4. 4 times 3 is 12. Negative 12 plus 12 is 0. So here's what that means. The 0 is the remainder. Okay? So we don't have to worry about writing a fraction at the end of our answer. Now, when you divide using synthetic division, okay, what happens is you are going to get a polynomial. And the polynomial that you're going to get is a 1 degree less polynomial than the polynomial you started with. So, whoops, I just colored over that. That wasn't very smart. Let's see if that'll work. Nope, that's not going to work either. Very interesting. Okay. I'm just playing with toys now. Yeah, that was terrible too. So anyway, so 3 is the degree. Okay, so we have a 3rd degree polynomial that we're dividing. The resulting polynomial is going to be a 2nd degree. And these numbers right here are going to be the coefficients of that polynomial. So the answer is 2x squared plus 3x plus 4. Now, I don't have to write anything after the plus 4 because 0 was the remainder. Okay? So that's our answer. 2x squared plus 3x plus 4. Now that's a degree 2. It's a quadratic, which is 1 less than the 3rd degree. And the coefficients came from right there. Okay? So, remainder theorem, if a polynomial f of x is divided by x minus k, which we just did, then the remainder is r equals f of k. So in other words, what that means is the remainder is you just take this number and you plug it in to the function. You just plug it in. That tells you the remainder. It doesn't tell you the function that you get. It just tells you what the remainder is going to be at the end. For example, if you want to find the remainder when f of x equals 3x squared plus 7x minus 20, when you divide by x minus 2, it says find the remainder. So if it only asks you for the remainder, all you're going to do is you're going to take, now remember, x minus k is the factor in the remainder theorem. So x minus 2, you're actually going to just find f of 2. So you plug 2 in. So 3 times 2 squared plus 7 times 2 minus 20. So 2 squared is 4, 3 times 4 is 12, plus 14 minus 20. So 26 minus 20 is 6. So the remainder, okay, the remainder, so in other words, if you go back to synthetic division, that number, that last number when you do synthetic division is the remainder. That would be the last number if you did synthetic division. 6 would be the remainder. And that's all they want to know. They don't want to know what the function is. They don't want to know what they just want to know what the remainder is going to be. So now here, because we don't have a lot of room, we're going to do f of -1 because it's x plus 1, but the formula or the theorem says x minus k. Okay, so this would be the same as saying x minus -1. So f of -1, so you plug -1 in everywhere you see an x. Okay, so -1 squared is 1, times 3 is 3, plus 7 times -1 is -7, minus 20. So our remainder would be -24. Okay, and then the same thing goes for this one. And I'll let you guys figure this one out, but all you do is just find f of -4. So you plug -4 in for x, and then you find out what that is. Okay, and again, that just tells you what the remainder is going to be. It doesn't tell you actually what happens when you take the polynomial divided by the factor. It just tells you what the last number is going to be. Okay, so the factor theorem, and we will discuss this more when we get into the worksheet tomorrow. A polynomial function f of x has a factor of x minus k if and only if f of k equals 0. So in other words, x minus 2 is not a factor of this f of x because this number was not 0. Okay? So x minus 1, or excuse me, x plus 1, not a factor because this number, the remainder, was not 0. And x plus 4, not a factor. Well, I don't know if it is a factor. Maybe we should find out. So 3 times -4 squared. So again, if we want to know if this is a factor, all we have to do is plug in -4 and find out if f of x equals 0. So let's see. -4 squared is 16 times 3 is 48. Minus 28, well, I'll be darned. We get 0. So by the factor theorem, what that means is that x plus 4 is a factor of this. Okay, so that's what the factor theorem is saying. Okay, let me just real quick explain to you the difference, and then we're done. The remainder theorem strictly says, okay, when you take a polynomial f of x and you divide by x minus k, all you do is take the k term, plug it in, and that will tell you what the remainder is. Okay, now the remainder can be 0, 5, -40, whatever. But the factor theorem says, okay, if you do the remainder theorem, if you plug in k to f of x, and you get 0 as a result, now you can go a step further and say that x minus k is a factor. Now, again, here we did x minus 2. We got a remainder of 6. So since 6 isn't 0, x minus 2, not a factor. Okay? And again, -1 gets plugged in. We didn't get 0. Now, again, for our purposes, it says find the remainder. We did that. But if it asks the question, hey, is x plus 1 a factor of this? We find the remainder. It's not 0. That's not a factor. And in C, it did happen that way. So we're going to cut it there. We'll do the first part of 2.4 tomorrow. Make sure that, I don't even know if, hopefully you guys have the notes for this, but if not, you guys can watch the video tomorrow. So I will see you then.